Hello everybody, how's it going today? My name is Connor, welcome back to another video. Today we're going to be talking about my game engine I've been running in Rust called Weaver. It's got an editor now, so that's pretty cool. I've also been working on writing my own scripting language to define the logic for the entities and the actors and the whatever you would call them in other game engines. So we're going to get into all that today. It's going to be good stuff. Before I start, I just wanted to talk about my 3,000 subscriber live stream that I'm going to be doing once I hit 3,000 subscribers. I'm currently about 30 to 25 subscribers away. So if you want to support my channel and see that live stream where I do a Q&A and work on Weaver and do a bunch of other stuff and have a really good time, then please sure to hit the subscribe button. And if you want to see more of my content, also hit the subscribe button. And if you want to have a comment and leave a comment, if you want to if you really like my video and you want to show support, you can hit the like or hit super thanks or become a member of my channel where I've been uploading content for members only again. So, little bloopers or outtakes of my videos or, little demo videos of my project. So let's talk about what is new. So obviously I have this new editor here. It's got, a few little panels. I'm using eGUI doc create for the dock interface. I can resize all this now. I couldn't even resize the window before, so that's progress, right? So, and as you can see, I can kind of move around the interface. I got a little grid here. I can select entities with the mouse again, so that's pretty cool. Got this little bounding box around them. I have this little scene tree over here where the entity that I'm selecting is going to be reflected in the scene tree and vice versa. So if I just happen to know that this one is what this one is, it's also highlighted and underlined. So, but I can select them over here and I can see what they are, what they actually are in the world. Eventually I want to have a better way to kind of reflect this and so you can know what entities are what, but until then, this is what we got. I can also rename the entities just to give them better names, just for that exact purpose. So I can get this one Robert. Name this one Robert. I'm going to name this one, rename this one Mandy. There we go. So, and if I, as you can see, there's a bit of a parent-child relationship thing happening going on here. We have this one, Robert is currently following around Mandy. Mandy's just spinning and Robert's just kind of rotating along with Mandy and also following Mandy's rotation with a little bit of an offset. And so if I want to go ahead and see those properties of the entities, then I can actually inspect their components now. So it's kind of more like a tree kind of graph structure with the ECS. And that's because I've completely rewritten the ECS in a new kind of way. So I'll get into that in this video as well. So yeah, so I can inspect these properties and I can actually also change them as well. So I can change this transform, move it up or down, move it left and right, forward, back, etc. I can also scale it. As you can see, the other monkey, the child, is actually inheriting that transform as well. So that's pretty cool. So, and I can also change the material properties. I can make them red. Currently, it changes both the materials over the material of both monkeys because it's actually using the same reference counter pointer to the same material. But it is what it is. We're working with what we got. So, yeah, and then I can change certain other properties. Right now, it only really works with transforms and materials. That's basically the only things I have on here. Although I do have another little component or a little entity that you can't see because it doesn't have a model attached to it, but I'm just testing adding components via script. So I can change those properties as well. But you can't really see it, so because it doesn't have a model. But anyway, so let's go ahead and dive into the code. So first things first is that I have rewritten the entire ECS and kind of entity component management way of doing things. Actually, let me just make it bigger for you guys. This is what we're looking at here is actually a script that I've written in a custom scripting language that I'm calling Loom, because Weaver and Loom, and it's kind of got a thing going on there. So and this script is controlling. Actually, it's defining a component called player, which has speed and health attributes, and it can do different systems at different stages. It can spawn the player into the world as an entity with that player component with it, and that's done in the startup system. That's the one that you saw in the demo, actually, where it had I had the player component with the health and speed. That's actually defined in the script right here, so it's pretty cool. And then the spin component, the spin system, it's getting a global resource of the time, and so it's constructing a quaternion to rotate the monkeys by a certain amount based on the delta seconds of since the last frame. And then it's querying for transforms and rotating that transform by that quaternion. So because both monkeys have both transforms, it can rotate them both. So anyway, so that's Loom, right? So this new ECS that I've been writing, I'm calling it Fabricate. It is its own crate within the source tree of Weaver. And what are some of the features of Fabricate that make it better than the old Weaver ECS crate that I was using, or that I created? First things first, in Fabricate, everything is an entity, and also everything is a component. So, or more accurately, components are entities. They have the same ID type, and they are, able to be stored within the same storage structures. So you can add a component to an entity, but you can also add an entity to an entity, or you can add a relationship of an entity to an entity, and you can add a component to a component. It's really flexible. It's a really awesome way of doing things that I've discovered recently, and I've spent the past basically a month working on implementing it into Weaver. So one of the other things, like I mentioned, everything is a component, which means I can actually add entities to entities in the form of relationships. So let's go ahead and take a look at that. So first things first, here is the registry RS file. And what the registry RS file is it contains two things. It contains implementations of IDs, which has a generic ID type, which is just a wraparound a U32, unsigned 32-bit integer. And then it also has the entity. It has entity meta, which is like a. Why is my symmetric highlight not working? There we go. It has the entity meta, which is like the second part of an entity, and actually has the entity struct itself, which contains an ID and an entity meta. So these are private fields. You can't access these on their own or change them on their own. You have to go through the methods of like ID and meta, So anyway, and in the entity meta, you can see we have a few different kinds of variants of what an entity meta can be. And you can think of the meta as like the metadata of the entity, right? So it's like the second half of the entity's identifier, and it's the second lower 32 bits of the 64-bit number that makes up the entity. So, and we can have a relative, which doesn't mean relative as in like this is relative to that. It's more so like, my mother is my relative, my cousin is my relative, So it's like a relationship between two entities in some kind of way, whether that's inheriting a transform like we saw with the monkeys in the demo, or it could be things like belongs to this world, or say I have one monkey that eats other monkeys, and I can have I can have a relationship between the monkey that does the eating and the type of component that marks that an edible entity. You know what I mean? So like, and because entity meta can also be just a type, it can specify. It can be generic over a bunch of different kinds of entities, or a bunch of different individual entities or components. So yeah, entity can either represent a generational entity, which is your typical like that's the monkeys, that's the the things in the world that you can typically see, or that you can typically interact with in some kind of way. It can either be a generational entity like that, it can be a relationship entity representing a relationship between two entities, or it can be a type representing a certain type of component, or something like that. It can also be a wildcard, which is something that's specially used in queries to kind of be generic over a certain type. Normally, with when you query for a certain type in a system query or in a world query, it only matches against both the entity ID and the entity type ID and the meta of that type. But you can also specify a wildcard for the second part, for the meta, and that will make it be generic over all instances of that first part of the ID. So maybe I'll put like a graphic on the screen or something at this point to show you just kind of how entities are structured and how they can work. Hello everybody, editing C State here. I wanted to quickly talk about what I was just talking about. So in the entity ID, there is actually two parts. There is an ID, and then there is a meta, as I mentioned. Like on this side, this would be the ID. On this side, this would be the meta. For every entity in the world, there is always just one part that's always just the ID. And then for the meta, it can either be another ID of a different entity, and that will be like a relationship. It can be a generational counter, specifying the generation of that entity and how many times it's been spawned and reused. Or it could be the same ID again, which would actually be a type entity. So, and these are all defined in the the Rust enums. So I can go over here and there we go, relative generation type. So anyway, and then the entity itself, it contains the ID and the entity meta, and it just continues in memory. So anyway, just want to go over that real fast. So I have the registry here. Where is it? There is the registry. Registry is kind of like a sub part of a world. Currently in Weaver and in Fabricate, there is only one registry globally. This is to make sure that you're not mixing different types of, different identifiers from different worlds and registries, which could break type safety and break memory safety in some cases. So everything has a unique ID globally across the entire process, across the entire version of that binary. This might change in the future if I can figure out a way to, safely convert between types of different registries. But until then, there's a global registry. You can have multiple worlds though. So the world is stored in a certain handle. I have this. God, it's hard to see when it's all zoomed in here. So I have this locked world handle that is used to refer to a world, and also an important feature here of the world handle is that I can actually do deferred mutable accesses to the inner world. So as you can see, what that means is, as you can see, the world is stored in the shared lock. So a shared lock is just a wraparound arc of a rewrite lock. So that when I clone this world handle, it'll still refer to the same world, right? And I have to lock it for reading or writing in order to access it. The thing is, I don't really ever lock it for writing unless I, more accurately, I don't ever like blocking write it for writing, or blocking lock. Sorry. So if you're not familiar with how a rewrite lock works in concurrent systems, typically you will have multiple. You'll use it when you have multiple threads all accessing the same information. And so how a rewrite lock works is you can have multiple reads of the write, or multiple reads of the lock at the same time across multiple threads, but only one of them can lock it for writing at a time. And if you want to lock the lock for writing, then you can't do that if there's any read locks that are currently outstanding, right? If any other thread owns a read lock at any point in time, then when you try to lock it for writing in the thread that wants to lock it for writing, then that thread will actually block and do a busy loop, or it'll do a yield loop in order to wait basically for the lock to be released on the other threads, so you can lock it for writing on that thread. And then once it's locked for writing on that thread, no other threads can lock it even for reading at that point. So it ensures that it's only being changed by one thing at a time, and when it's being changed, nothing else can access it until it's been released from being changed. So that's how rewrite lock works. And so one of the issues with that is that if you try to lock it for writing in the same thread that's already locked it for reading, then you can deadlock, which is where the same thread, where a thread just kind of busy waits forever and doesn't ever get released because it's waiting on itself, right? So I actually have this kind of, I think, a kind of clever way of doing this, where I have this defer method on the locked world handle. This isn't part of the world itself. This is just on the world handle that's shared around everywhere and locked everywhere. So what the defer method does is it will first try to read the world. It will try to acquire a read lock on the world. If it can't, then it will fail with an error. Once the read lock on the world is acquired, it will create a new command queue. And what this command queue is this is something that has its own shared rewrite lock on a queue of commands. And what the commands do is they allow you to queue up things to do to the world that require immutable access to the world, right? They require a write lock on the world. So things like spawning an entity, which requires creating a new table and archetype in the storage, right? That requires very much immutable access. So and you can do things like despawning an entity, which does the same thing. It requires creating tables and moving tables around and deleting tables and stuff. It's very, very messy. Adding components, same thing. Adding a system, and also garbage collecting the dead entities in the world. So all stuff to do with the storage for the most part. But the thing is, you can push commands to this queue basically as much as you want, because the write lock on the queue is only active for as long as you're actually pushing a command in, which is like a very small amount of time. So it's pretty much safe to always push a command to this queue. So and what the command queue does is it will record all the commands that you're trying to do to the world while it's currently being locked for reading. And anything you want to do that's mutable to the world, you have to do it on the command queue instead. So and then after you're done doing your stuff with this function that you pass in, this is closure or something that you pass in, that takes a immutable shared reference to the world and a mutable reference, unique reference to that specific instances of defers command queue. And then once you're done doing your stuff, we drop the read lock on the world as fast as we can, so that we're not trying to deadlock at any point. We then so there's a second part to the locked world handle, and that is actually that you have a kind of like global command queue, right? And this isn't actually a command queue, like an actual object that holds onto the lock of the world as well. This is just like a spare kind of like scratch pad of commands. And what we do is we write our command queue, or our internal command queue of the world handle, and we push all of those commands that we just recorded into that queue. And so this ensures that those commands aren't lost in case the next part fails, which is where we attempt to acquire a write lock on the world. And if we are able to acquire a write lock on the world at that point in time, if it doesn't deadlock, if it won't deadlock, I should say, this will never deadlock. This try write will never deadlock. It will always just return error or none if we aren't able to acquire a write lock on the world at that particular point in time. But say we are able to acquire a write lock on the world, then we actually lock our world for writing, and we apply all those commands in the order that they happened. So it's able to kind of do a big dump of all of the we need to do this and this and this and this to the world before we continue with what we were doing. So it goes ahead and does all that. And that's what this finalize method does. it'll just, do all the mutable. And as you notice, all these require mutable access to the world. Mute self, mute self, mute self. So, yeah, anyway, that's kind of, my solution to that problem that I had earlier. That where I was deadlocking with writing a world all the time, it was just getting really annoying. I just deferred the write lock of the world to when I'm actually able to. Now this does have a few consequences and side effects where sometimes I'll have some code that's expecting a command to be finalized on the world and it actually isn't, but this is a trade-off to everything, right? So and it will eventually get finalized to the world as long as I don't hold on to a read log for the world like forever, which I'm generally careful about not doing when it comes to things like that. So just whenever all those read logs are dropped, it'll automatically just kind of, flush the command queue and finalize it all on the world at the same time. So you might ask, why am I doing this? Why am I creating this brand new ECS for my game engine? So the answer to that question is because the old version was getting really messy. It was just really kind of not working out. It was very hacky. It was very kind of hastily written. I really wanted to, now that I know how to create an ECS and how to implement certain features in ECS properly, I wanted to just kind of start over and just kind of take it from the beginning. And yeah, anyway. So what's next? First things first is I want to flesh out this Loom scripting language that I've created. I want to be able to, so you can see I can create components at runtime here, but I want to be able to access these fields of the components in the script itself, like in queries or something. Right now, these aren't very useful. I also want to be able to define functions, like just custom functions. Like I even have a keyboard for it already. Func, foobar, and I can do like return 42, stuff like that, But that's actually not implemented yet, and I'll get an error if I try to run this script. So, and also just defining functions on components themselves, like methods of some sort. So, and then just adding more editor functionality. Like I said, it's pretty unfinished right now. Adding the ability to spawn components into the world, maybe move them around between parent-child relationships of some sort. Maybe adding a script editor for the scripts. I actually had that at one point, but I had to remove it because I switched to EUE doc and it was just so anyway, but yeah, that's about it for this video. Thank you all very much for watching. I will like I said, if you want to see me do that 3,000 subscriber live stream, I'll roll with it. Live stream. If you want to see me do a 2,000 subscriber live stream, then go ahead and subscribe. If you want to see me make more of these videos and you want to support me and encourage me to continue making these videos and these projects, hit the like button and leave a comment. And I'll see you all next time. Thank you all very much. Peace out.